The next topic that we're going to be looking at is how we use logarithms to solve equations where the unknown appears as an index. So we're just going to recap what we did last time, which was the multiplication rule, the division rule, and the power rule. We're going to use these and there's some footnotes here as well, which we also referred to. So the kind of equations that we're going to solve are ones like this. 3 to the x equals 20. So what we're going to do is we're going to do the same thing to both sides of the equation as we did lower down the school. So we're going to take log of both sides of the equation. So this could be the log of any base. So it could be base 10, could be base 2, it doesn't matter as long as we do the log of both sides. On this left hand side, we're then going to use the power rule that we learned last time to rewrite this as x log 3 equals log of 20, and then we're going to divide both sides by log of 3 because this is just a number. So x equals log 20 divided by log 3, which we can now do on our calculator. So I'm just going to put base 10 in on mine, divided by log 10 of 3. And that gives me the answer that x is 2.72. So we could do a little check there and check that 3 to the power of 2.72 is approximately 20 if we're unsure. And this bit here, it's worth noting, this is not the same as log of 20 over 3. It's not the same. You can check that in your calculator. So let's look at another example, a little bit more complicated. Let's go back to the blue pen, but again we're going to apply the same logic. We're going to take the log of both sides. So we're going to do the log of 7 to the power of x plus 1 equals the log of 3 to the power of x plus 2. And again, we're going to use the power rule to rewrite that. So I'm going to use brackets. So I'll get x plus 1 times the log of 7 is equal to x plus 2 times the log of 3. And what I need to do is expand the brackets, collect the terms with x on one side, the terms without x on the other, so it allows me to factorise and isolate x. So this becomes x log 7 plus log of 7 is equal to x log 3 plus 2 log 3. So let's take this away from both sides and take this away from both sides. So I end up with x log 7 take x log 3 is equal to 2 log 3 take log 7. I can factorise this side, so we get log 7 take log 3 is equal to 2 log 3 take log 7, and then I can divide through by this term to give me x is 2 log 3 take log 7, all divided by log 7 take log 3. And if you shove that all into your calculator, then you get x is 0.297 to 3 significant figures. And again, you could check that back in the original equation. So I'm just going to have a look at one more similar sort of equation to what we've done, and again we would just take the log of both sides. So we get log of 7 to the 2x take 1 is equal to log of 23, and most people would probably use log to the base 10, but sometimes in exams they tell you what log to use, what base, because sometimes there's some useful simplifications that perhaps make use of some of these rules. So if we carry on with this one, I'm going to use the power rule again. So I've got 2x take 1 times the log of 7 is equal to the log of 23. I'm going to need to expand the brackets to get at the x. Take log 7 equals log of 23. I'm going to add log 7 to both sides and then divide through by 2 log 7. So I get x equals log, just write that out. So I get x is equal to log 23 plus log 7, all divided by 2 log 7. So again, if you want to put that through your calculator, you can work out that x is 1.31 to 3 significant figures. So we're now in a position to have a look at exercise 14G in the Year 1 book. If you want to have a look at a bit of a challenge, you might want to have a look at a question like this, and what hopefully you might be able to see is this is a quadratic in 5 to the x, so we could use a substitution technique and say that let's call y is 5 to the power of x, and this equation can be written as y squared plus 7y take 30 equals 0, and then we can factorize that as y and y. We've got 10 and 3, so it's plus 10 and take 3. So y is 3, or y equals negative 10. And then we can sub this back in. 5 to the power of x equals 3, or 5 to the power of x equals negative 10. So we'll see some interesting results here. So let's do log of both sides. So if I do log of 5 to the x equals log of 3, x log 5 using the power rule equals log 3, and we get x equals log 3 over log 5. If we do the same over here, let's do log of 5 to the x equals log of negative 10. There should be some alarm bells ringing already. So we get x log 5 equals log of negative 10. So x equals log of negative 10 over log of 5. So if you go to your calculator, if you do log to the base 10 of negative 10, we get, let's go back, we can't do this, we can't do the log of a negative number, we get a maths error on the calculator. So if we did the base 10, it would be saying what power of 10, what number do I raise 10 to give me negative 10, which we can't do. So if you look back at the starting lesson, you'll see that